Here are the key facts that you need to know about friction. Friction occurs when objects are on rough surfaces or experience air resistance. Friction acts in the opposite direction to motion. Friction acts at right angles to the normal reaction R. And remember, the reaction R always acts at right angles to the surface. Therefore, friction acts parallel to the surface. F, friction, is less than or equal to mu times R, where mu is the coefficient of friction. So that's just a measure of how rough something is, and it has no units. Limiting friction means that the friction equals mu R, i.e. friction is at its maximum. So if it says that something is on the point of moving, use F equals mu R, or if something actually already is moving, use F equals mu R. Here's an example involving friction. First thing that they want us to do here is to determine if the force Q, which is 25 newtons, is sufficient to make this particle move, given that it's on a rough surface and therefore friction is in action. So we know that friction equals or is less than or equals to mu R. So the first thing that we need to work out is what R is. So by resolving vertically, we can see that R equals 8G. So F is going to be less than or equal to 0.4 times 8G. That's 3.2G. And if we work that out in newtons, that becomes 31.36 newtons. So because the friction is greater than the force Q, it will not move. So the second part of the question says, if Q is 40 newtons, what will be the acceleration? So we can see that that's greater than the friction, so it would definitely be moving, and there will be an initial acceleration as a result. And that's what we're going to work out. Now to do that, I need to introduce a new rule. So this is Newton's second law, and it says that F net, and what's F net? F net is the overall resultant force in a particular direction. So F net equals ma. So m is the mass, a is the acceleration. So let's find F net in this situation. So F net here will be Q minus the friction. So we're told that's 40. And the maximum friction we worked out previously as 31.36. So that means that the net force is 8.64 newtons. So 8.64 equals the mass, which is 8, times the acceleration. So the acceleration will be 8.64 divided by 8, and that works out to 1.08 meters per second squared.